Okay, so today we're going to be doing lesson 4, which is permutations when some objects are identical. To describe this, we're going to say, okay, before when we were doing, I'll just do this part right here. We have the letter B, B1, O, and B2, okay? And we'll treat the B's as two different letters. So how many ways can we arrange this, okay? If we used a fundamental counting principle, we would say, okay, there are 3 different possibilities for the first letter. There are 2 different possibilities for the second letter, and there's 1 remaining for the last letter, which is equal to 6 different ways of doing it. If you wanted to use the permutation, you would do 3, pick 3 in your calculator, which also equals 6. Okay, so when that happens, everything's good because all 3 of these things are different objects, so are letters. But if we go to question 2, we know B's are actually the same. So how many different arrangements are there? So if I have BOB and I wanted to arrange this, okay, we know BOB is one arrangement. We know that OBB would be another one. Okay. And then we could go BBO. But now these would all be different. And if we went BOB again, right? These would be different arrangements if we were still dealing with B1 and B2. But now we know that B's are the same. So this arrangement and this arrangement are actually the same. So we don't want to count it twice. So what we're going to do now, another way is 3 factorial would be, these are the 3 ways of counting this. What we're going to do now is we are going to use the same type of counting, but we're going to divide by something. So in the previous lesson, we looked at a number of possible arrangements when they're all different. When there are repetitions, the number of permutations, which is n factorial, so the number of objects, where A and B and C are one type, can be represented by, okay, so basically this is a fancy way of saying all the total number, factorial, and then you divide it by the ones that repeat. Why they have ABC is because if you have multiple letters that repeat, you'll just calculate them separately. So when I go back to Bob, we have 3 factorial. That's the total letters, B-O-B. But we have 2 B's that are repeating. So that's why we're going to divide it by 2 factorial. So that is 6 divided by 2, which is 3. So really, there are only 3 ways of arranging it when B and B are the same. And those would be right here. So let's do a few more examples. Mississippi. Let's just use the thing we did on the last slide. So let's count how many letters we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 total numbers, or sorry, letters. But now we see that the I's, the S's, and the P's repeat. So we are going to have to divide by those. So we have 1, 2, 3, 4 I's. You must account for those. We then have 4 S's, so you must account for those. And you have 2 P's, so you must account for those. Then, if you take out your calculator, it will be a long number. And while my calculator loads, I'll do the next one. So, oh, here it is. So clear this. We're going to go 11 factorial. Let me record it. (11 factorial divided by 4 factorial, another 4 factorial, and 2 factorial. So the total number of possibilities, 34,650, which is a lot smaller than just going 11 factorial, which we would have done in the last lesson if all the objects were different. So Calgary, 1, 2, 3, 4, 5, 6, 7, 7 total objects divided by 2 A's, which repeat, and you just put that in your calculator. Mathematical, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 factorial over, I see 2 M's, I see 3 A's, and I see 2 T's, H, no, E, no, L, no. Okay, so 12 divided by 2, 12 factorial divided by 2 factorial, 3 factorial, 2 factorial. Okay, that'll also be a numbering calculator. You can get that. Kukanusa. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. You have 9 total. And I see we have 2 O's. We have 2 A's. And that's it. So when something repeats, you just have to take the total and divide it by the objects that repeat. All right, moving on. This is just not using words anymore. So let's try different types of questions. Naval signs are made by arranging colored flags in a vertical line, and the flags are then read from top to bottom. How many signals can be made using 6 flags if you have 3 red, 1 green, and 2 blue? So pretty straightforward. 6 total, 3 repeating red, 2 repeating blue, and 1 green. So that would be 6 times 5 times 4 times 3 times 2 divided by 12. And that's 60 different ways. Okay, question B. Same principle, 6 total flags, but now you have repeating of all of them. So 2, 2, and 2. And you get that in your calculator. How many ways can 8 marbles be pulled out of a bag consisting of 4, 3, and 1? So 8 factorial in total, but now you must divide by the stuff that repeats, because if you pull out a red marble first, that's the same thing as pulling out another red marble first. Okay, moving on. So this is, and then another question. Howard has 10 mini boxes of cereal, 3 corn pops, 2 Rice Krispies, 1 bran, and 4 shreddies. How many different are possible? Okay, so we are gonna go 10 in total, divided by 3 repeating, 2 repeating, and 4 repeating. All right, and that will equal a number. And you would just have to write down what the number is. Okay, if Howard wants to eat a box of Rice Krispies first and 1 box of corn pops last, how many different orders are possible? Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we have 10 possible, we have 10 objects. This has to be a corn pop right here. And this has to be a Rice, or sorry, I mixed that up. This has to be a Rice Krispie. And this one has to be a corn pop. Okay, so this is gonna get a little bit complicated when this is called repeating objects with restrictions. So when we go to do Rice Krispies, we know that there's 2 ways of thinking about this. You can do, there's 2 Rice Krispies, but they're repeating, so 2 over 2. But another way of thinking of it is if you need a Rice Krispie first, there's only 1 possibility, right? If you need a corn pop first or last, there's only 1 possibility. So when that happens, we're gonna have 2 corn pops left, and 1 Rice Krispie left. So really, we now have 8 factorial left in the middle, but we still have some repeating. We have 2 corn pops, we have 4 Shreddies, but now there's only 1 Rice Krispie and 1 Bran Flakes. So we don't need to put 1 factorial, 1 factorial. Okay, so when you have restrictions, just be careful. Now, I know there are 4 corn pops, but if your corn pops need to be last, it doesn't matter which one of the 4 you pick, they're all the same. So you don't have 4 possibilities there. You only have 1 corn pop at the end. Okay, moving on. We're going to go over these pathways and then one more thing. So exploring routes using permutations. This is always on the diploma. Fortunately, you guys don't have a diploma this year, but this is how you would do these. You need to count the ways that you need to get from home to school. So, and you can only go to the right or down. You can never work away from school. So meaning if you go to here and then down, you don't ever move away from the school. So that wouldn't work. So it's always either going straight and down and over, something like this, right? To get to school the fastest. So how we do this, we're going to use numbers. So to go from this point to this point, there's one way. To go from this point to this point, there's one way. So if I were to choose 2 routes here, I could go from here to here. That's one way of getting there. And then I could also go from here to here. And that's another way of getting to here. So really, there are 2 ways of getting to that point. Another way of doing that is if you add the boxes here, this and this, it will always give you this number right here. So if we continue with this pattern, there's only one way of going to here. You always do it at the intersections. There's only one way. That should be a 1. There's only one way, and there's only one way, okay? Because you always have to move towards school, so there's one way of getting to these intersections. Okay, and that means there's still one way and one way. But now, if we continue with that principle, there would be one way of going to there, right? There would be another way of getting to this point, and then another way of getting to this point. So I just drew 3 blue lines. But if I just add this number and the corner number, it will always give me the next corner. So if I continue with this, 1 plus 3 is 4. 1 plus 4 is 5. This is just a quick way of determining how many there are. And if we do this, look at, that's 3, that's 4, and keep going. That's 3 plus 3 is 6. Now the numbers are getting a bit bigger. 4 plus 6 is 10. That's 20. Okay. This will be 15, 21, 6 and 5, 15, and then 35. And then finally, 56. So we determined there's 56 different ways of getting to school. Now, you're not going to draw 56 lines over this. It's going to be a mess. Okay? So that is how you do these pathway problems. If you wanted, there's a way to do it with permutations. You are going to take the number of routes here. Just a second. Got to bring up my calculator. So if you want to use permutations, you are going to count how many ways there, or how many boxes there are on the outside. So we have 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 total ways of going down or across. But now you must divide it by the repetition. So there are 3 repeating down. So 1, 2, 3. And there are 1, 2, 3, 4, 5 repeating that way. So this should work. 8 factorial divided by 5 factorial, and then 3 factorial. And it will come out, oh, I didn't put the division. 8, you have to redo this here. And 3. And there you go, 56. So if you count the number of down and across, and then divide it by the repetition, you will get the same number. And this will help when we go to do ones that are broken up. So we can do the counting way, so I'll do it again. But instead of that, let's do permutation. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are trying to get from here to here. So there are 9 ways for this box, but there are 1, 2, 3, 4 repeating down, and 1, 2, 3, 4, 5 repeating over. Okay, so you would calculate that, and it will equal, just a second here. It would equal, if we did this, it would equal 126. So if we were trying to go from this point, A, to B, it would be 126, like last question. But now we're trying to get all the way to C. So what you have to do is calculate the same method for this box. So 1, 2, 3, 4, 5, 5 factorial over 3 down and 2 across, which equals 10. And then you would take this number times it by that number, so 126 times 10 is equal to 1,260. So there are 1,260 ways of getting from A to C. Now, if you tried to do that by just drawing lines, you'd be there all day. Okay, so let's do this one. You have 3 separate boxes, so you're going to calculate each box separately. So this one has 1, 2, 3, 4, 5. So again, 5 factorial over 3 and 2. Then you have 1, 2, 3, 4. So 4 factorial over 2 and 2. And then you have 1, 2, 3, 4, 5. 5 factorial over 3 and 2. Okay, so what that is going to equal is this is going to equal 6, 10, and 10, and then multiply them all together. So it's still 600 ways to go from A to B. Okay, moving on. The last thing we're going to do today is we have to learn how to solve these. There are some of these in your assignment. So let me just pull up the last lesson so I can get the formula. And it's no different. Basically, here, this is a challenging one. Let me just redo this question so that it starts off just like this. 7PR is equal to 210. So before we would be like, okay, there's 7 objects and you're picking 2 of them. 7, pick 2, you plug it into your calculator and you get an answer. However, we want to make your life a bit more complicated. So we're going to say, okay, there are 210 ways of doing something. You have 7 total objects. How many did you pick? So how many were chosen? Now, you can do this using guess and check. It may take you forever. So what we're going to do is we're going to use the formula. All right? So that is right here. I'm just going to give myself a bit more space. Here's the formula. So what you want to do is you want to go 7PR is equal to 210, but NPR is equal to this. So what we want to do is say, okay, 210 is equal to, and then start replacing this stuff. 7 factorial is the N, and then 7 minus R factorial. Okay? So once we do that, I'm just going to get rid of these just so I have lots of space. Okay, let's go back to this question. What you want to do is you want to solve for R, okay? So how we're going to do that is we are going to go 210. We are going to start solving. So 210 is equal to 7 factorial over 7 minus R factorial in brackets. All right. You need to get the variable by itself. So using isolation, we will end up with this. You're going to multiply both sides by 7 minus R factorial. And that is going to equal 7 factorial over 210. So I don't know if you remember from trigonometry from grade 10, we had this little thing where you can actually just flip the fractions instead of doing all the, so switch them place instead of doing all the multiply by 7 minus R factorial, divide both sides by 210. I can do that over here if you'd like. So we would multiply both sides by 7 minus R factorial. And then you would divide both sides by 210. And you would cancel, and you would end up with this. Okay, so we're right here right now. All right, you can just do 7 factorial in your calculator. And you can divide it by 210. So 7 minus R factorial is equal to 24. So the easiest way of doing this is saying, okay, what number factorial equals 24? Right? So you can try like 3 factorial is equal to 6. And 4 factorial is equal to 24. Okay, great. So we know that 4 factorial is equal to 24. So we can go 4 factorial is equal to 7 minus r factorial. So 7 minus what is equal to 4? 3. So basically, you picked 7 at the beginning and you chose 3. 7 pick 3 is equal to 210. Okay, so that's basically how you do those ones. And there is one of them on your assignment. Okay, let's go over another one, just so it's pretty clear. Now, as you can see, for this one, remember our last question started out like this: 7 pick what equal to 10. Okay, so I was able to change it into the formula right away because there was no number in front of here, right? You always have to have this thing by itself so you can switch it. So the problem here is that you have a 3. So just to start, make sure the permutation is by itself. So once you divide by 3, 12PR is equal to 285,120 divided by 3, 95,040. Okay, now they're big numbers, but it's not a big deal. The next step is to change that. So 12 factorial, we're going to change the 12 PR into the formula. Okay, we're going to do that. Let me just continue over here. We're going to do that little switch. So 12 factorial over 95,040 is equal to 12 minus r factorial. Okay, you can just do that in your calculator. 12 factorial equals 5040 is equal to 12 minus r factorial. Okay, now it's your job to figure out what number factorial equals 5040. So you'll do a little bit of guess and checks. And it will equal 7 factorial. So 7 factorial is equal to 12 minus r factorial. So r would be equal to 5. 12 minus 5 is equal to 7. So there you go. Okay, the next one. Here. This is a little bit different because this time we're not giving you n, right? So this time it's you had a total, and there's a multiplied by 7 in front. So let's just get rid of that 7 right away. Divide both sides by 7. And 1274 divided by 7 is equal to 182. Okay, so basically, how many objects were there where you picked 2 of them and it equaled 182? So n factorial over n minus 2 factorial is equal to 182. Now, this looks a lot like the previous lesson. You take the bigger factorial and expand it until it cancels. So n minus 1 factorial, or sorry, n minus 2 factorial. So I'm taking the top and I'm expanding it so that it matches the bottom. Remember, always take the bigger one and start subtracting. So when I get to that, I can now cancel these. Okay. So I'm left with n minus 1 factorial, or sorry, not factorial, equal 182. And this is going to be a quadratic problem. So n squared minus n minus 182. N squared minus n minus 182 is equal to 0. You will then factor these. So n 182 divided by, sorry, let me just figure out the numbers. It's 14 and 13. Okay, and so n is equal to 14, and n is equal to negative 13, and we'll reject this one. So there were 14 objects at the beginning. Okay, that is this lesson. So that is permutations with repeating numbers.